All right, so yesterday we talked a bit about circles. I got a handout too, just in case you're going to leave early. You got a little handout you want to grab before you leave. So the basic form of a circle, for a circle centered at the 0, 0, it's like that. The center here would be 0, 0, and the radius would be what? R. Square root of R squared, so R. If I want to move the center around, I shift it. Second?
This is 15.
Yeah, this is 15.1, yeah. If I want to shift it around, I do that. So this would be a center of HK, and a radius is still R. So real quick, let's try to graph a circle from its equation. And I'm going to make it so that we have to do some completing the square. Yay! Let's make it. Give me a second. I'll make it so that it's easier to graph. So it's just like a line, believe it or not. It's just a little more complicated, obviously, because the damn thing needs to turn around on itself. So the equation is going to be a little bit harder, but if I put it in the right form, everything about it jumps out at me. So with lines, it's mx plus b. If I solve for y, everything falls into place. With circles, if I collect all my x stuff together, all my y stuff together by completing the square, right? Yes, I did just say together. Put it together. So here I want to complete the square. There I want to complete the square. So now I just got to figure out what goes there and there. So what goes here for this? 9. Good. Half of this is negative 3 squared is 9. 4. Half of 4 is 2 squared is 4. So now I get x.
Minus 3. I told you completing a square had its own purposes, and so you have to be able to complete a square to get this in the right form. Now, what do we know about this circle?
Its vertex is negative 3, 2, or center.
Center, good. Is careful.
Negative 3.
Careful.
No, 3, negative 2.
So we're always fighting against what this is. So minus 3 in here actually shifts me positive 3 over. All my inputs have to be 3 bigger. All the y's can be 2 smaller now. Because the first thing I do is add 2 to them, right? So that's how that works.
No, that's why I was asking for a little break because I needed to piss. But what's
And your radius is 4.
Yep. What's up?
Chris, please re-explain everything.
All right. So yesterday we talked about this. Really just comes from Pythagorean theorem, because the definition of a circle is all the points that are equidistant from the center.
Okay.
So if I have that distance is r. So this is x and y. Right? So that would be x squared plus y squared equals r squared. It's Pythagorean theorem. It almost seems too simple, but that's exactly where the equation comes from for a circle. So if you can say in English what the definition of some shape is, then you can take that definition and apply it mathematically. You get the equation for that shape. That's crazy. That's actually what all conic sections do. Ellipses have certain definitions. Hyperbolas have certain definitions. And you all know that planets travel in an elliptical orbit. Comets very often come in either parabolic or hyperbolic comets that come in. You guys know that?
No idea.
Comets. You know that comets come sometimes?
Yes.
Yes. What do you mean you do now? So they're coming, go around the sun, go back out. Anyway, so that's one reason why we want to be able to know the equation so that we can see ahead of time, oh look, it's moving. Is it going to hit us?
Let's make the equation. Oh, good, it won't hit us and kill us. Okay, good. So math is kind of good. Saves all of us. So center is 3, negative 2. What's the radius? 4, good. 4 squared is 16, so the radius is 4.
And that's all you need to go ahead and draw a circle, right?
Yeah, so now I can draw the circle. So the center is at 3, negative 2. So 3, negative 2. There's the center. You put a little open circle there because it's not really part of the graph, right? And then how far out do you want to go from that center? 4 away. So if I go 4 up, 1, 2, 3, 4 up, 1, 2, 3, 4 over. Oh, this is so tilted, it's crazy. Let's do that. 1, 2, 3, 4 back, and then 1, 2, 3, 4 down, and then I just very carefully attempt to draw a circle. And I get Stewie. Almost. Anyway, so that's how you would. So they ask you to find the center and radius of the circle and then graph. Bam! That's exactly what I want to see, right? The only difference between a circle and an ellipse, well, visually the difference is what? What's an ellipse visually?
Half a circle.
It's not half a circle. It's a hemisphere or half a circle. Second, squished, right? It's even more like Stewie's head. So it's like a circle somebody sat on, right? It's like a football, right? What? Oh, hey, Arnold. All right. That one I don't know as well, but sure. Thanks for that reminder. So this would be a circle of radius 3 centered at 0, 0. So this is a circle. The only difference for an ellipse is that one of the coefficients, the two coefficients of those are not the same. Kind of with me? So real quick, before we go to ellipse, this is a circle also. That's a circle.
So if you change it,
Because I can divide by 2, right? So if they're the same coefficient, I can just divide it away and I get back to normal circle, right? If they're not the same coefficient, that means the x and the y don't operate the same way. That's exactly an ellipse. If I go further in the x than I do in the y, I get a squished ellipse that way. Further in y than I do in the x, I get a football sitting there like that, right? You guys kind of with me? So if I put in my equation 4x squared plus y squared equals 4, for example. I like this. We're going to do this real quick. How big, let me see if you guys can just look at this and think about this. How big could x get?
4 times.
What's the smallest y squared could be? 0. You mean a negative number in there is positive, positive. So the smallest x could be is 0. So the biggest x could be would be when the y is the smallest. The biggest x could be is 1. So I can only go out to 1. Now how big could y be? Y can go out to 2. So you see, changing the coefficients changes what those things are allowed to do, which makes the picture look different. So now y can go out to 2, and there's my ellipse. You kind of with me? Now, there's a lot more to it than this, obviously. But if all you needed was the graph, it's that simple. You just find the extremes and then connect them. If I wanted an ellipse that's centered somewhere else, what would I do? I want the same ellipse, but I want it to be centered at negative 4, 3. How would I change the equation? Don't overthink it. Why was the center here 3, negative 2?
because you put the
Because I put the negative 3 in there. So how would I make negative 4? What would I do with this? Plus 4, hey. And then what would I do there?
Y minus
Y minus 3. There you go. Now that would be the same damn picture, except it would be centered at negative 4, 3. Same football, just move it up here, right? Do you guys kind of get that? Just like a parabola, if I change that, it just changes the vertex, but the shape stays the same. It's still a freaking U. I just move it around. Same thing happens with any function, actually. So obviously it's going to happen with an ellipse or a circle. Maybe. The main thing I want you to get from there is, if I gave you that versus that, you could tell me that's an ellipse, that's a circle. Yes, sir?
That's mainly because both X and Y have the same. Before it's not.
Good. So they have the same coefficients.
Right, there you go.
That's why these are circles, because they have the exact same coefficients. Anytime they're at all different, an ellipse. If they're a little bit different, it'll be an ellipse, just barely. It'll be a circle that somebody just kind of brushed up against, right? If they're very different, it'll be a circle that, somebody really just laid down on. Whatever. Ah!
It is not a circle if it's minus, right? So those two.
Good, I like it. So the next thing is hyperbolas. So here we got circles. That's an ellipse, really. Who cares? Let me make my ellipse really major. There's an ellipse, right? And I want you to. I want to. Let's see if I can.
So just a quick question about. So with the circle that you just erased, you find your center, and then you just go out your 4 points or your
Yep.
radius, and then
Exactly, and then just connect them as best you can, right? I won't be jealous if you can make a better circle than me. It's okay. It's not difficult to make a better circle than me, so I can't be. See if you guys can understand this. If I said two positive numbers add to be 4, let's say it like this: two positive integers, or two whole numbers add to be 4. How many options do I have? It could be 0 and 4.
1 and 3.
1 and 3,
2 and 2.
2 and 2, 3 and 1, 4 and 0, right? That's it. So it's contained. So when I have a plus in here, this is coming off of what Mike just said. If I have a plus in here, I'm going to have some kind of contained thing. It can't go forever out. There's only it can only go so far. So if that's 0, the most that could be is 3. So that's why there's no way x could ever be bigger than 3. If I put a 4 there, what do I get? I get 16 plus a positive number is 9. How the hell are you going to do that? You can't. So it's contained. If I said two numbers difference is 4, there's no limit. 16 and 12, 804 and 800, a billion and 4 and billion. You can keep going forever. You with me? So it's not contained. So that's why if I have x squared minus y squared equals 9, that is a hyperbola, because it keeps going forever out. So it's sort of like the opposite of a circle in a way. Here's a circle. Hyperbola would be like that, maybe. It goes out. So that's why comets have these hyperbolic orbits. They come in, and then they go out. Here's the sun. They come in, they go out. They never come back. Bye. Some of them have elliptical orbits. Some of them have parabolic orbits. Yeah.
So when that is a minus, it's a hyperbola?
Good. So if it's a plus, it could be a circle or an ellipse. You just got to look at the coefficients. If it's a minus, I don't care what the coefficients are doing. It's a hyperbola. I like it. I like it a lot. Okay. See if I want to say anything else there. So it doesn't matter if I made that a 9 or whatever. It's still going to be a hyperbola because of the minus sign there. And then the same thing I can do, this would be centered at 0, 0. If I wanted centered somewhere else, I just throw numbers in with the x and the y, same way we did with the other two. Now that actually is the level I wanted to discuss these. I want you to realize that if you do go to 176, you will discuss these at a much deeper level.
Get a count.
Second? Yes, actually, real quick, since you said that, I forgot. I want to show you, these things are called conic sections. And the reason they're called conic sections is because they're sections of cones. It's crazy. I know. So in the book, there it is. Give me. How could I tell where it was until I got it up? So if I have this, these cones set up opposite each other, if I slice it in certain ways, if I slice it right down the sides, I get a line out. If I slice it like that, so I don't slice the other piece, I get a parabola. If I slice it straight across, I obviously get a circle. If I want a bigger circle, I just slice it further up. And then if I slice it tilted, I get an ellipse. And if I slice it straight down so I go through both, I get a hyperbola. So that's why it's called conic sections, because they are sections of cones, these cross sections of cones. It's kind of neat. All right, so you guys are like, sure. There's a lot more into what else you could do with these cones, but that's obviously a little bit deeper and later. Okay. Yes, ma'am.
So say you got that.
Say again?
So say you got that.
Yeah, I mean, obviously this is really, trust me on this, there's a lot more to a hyperbola. And actually on this little handout, I just want you to have this in case you're going into pre-calculus. You have this to kind of reference. This goes a little bit deeper into the parts of hyperbola.
You mean the x squared minus y squared over a squared minus b squared? Or the thing that it talks about there.
X squared over a squared, yeah, exactly.
Yeah.
So again, just to remind you guys, section 15.1 homework is due. Section 15.2 and 15.3 is not.
You're not even posting it on my math lab, are you?
No, so you can do it if you want. Maybe I will. Just separate
No, you don't have
with 0 credit.
to. You don't have to. I don't want to see it because there's a part of it where you like, it's not a very big part. But there's
Okay.
it's complicated. You want at it? I don't want it. I don't even know how you get to where they're talking about.
So the first one I gave you is the circle example. So that's the one you're required to know how to do. Like the problem we did earlier with completing the square. The rest of this is really just for your own personal edification. So do as much or as little of the rest of it as you want to look at. If you're going into pre-calculus, you might want to try a few things out. But normally in pre-calc, we kind of start as if you don't know a damn thing about it. Anyway, so that's why I don't feel too bad about not getting too much deeper into this.
Is that how you're going to start pre-calculus?
Yeah, yeah.
Okay.
Well, pre-calc doesn't start here. Don't get me wrong. We eventually get here, and then we go deep, right? Yes. So, what I want to do for the rest of the day is basically whatever the hell you want to do with the rest of the day, which is we can talk about the practice final. We could do some problems from 15.1. You can work on finishing homework. You can work on corrections. Oh, I don't really know too much. That's why I didn't say anything. I don't really know.
176.
Like where's the shot?
When I say that I don't know too much, I actually mean I don't know a damn thing. Besides, it's F.
I haven't even
Say it before, I'm not even sure that's the right way to say the last name.
Okay, so I don't have to take any other math classes. I just have to be, because I'm trying to think of when I'll be able to use this outside of math class.
You never know. That's the one reason why you want to know it, in case it comes up. Is it working?
Check their staples in there, but maybe it's jammed or something. And then I had a quick question. If I have everything enough to get a C, because I don't need to go higher, it's a pass or no pass thing? Is a C minus still passing?
There's no such thing as a C minus.
Okay.
Yeah.
Okay.
So I didn't list it, and it's actually Title V, which is education law. It says you can't have a C minus. So no school could give a C minus in California.
And these are my test questions. I'm taking the test today. Do you want me to turn them in?
Oh, if they're ready, yeah, sure.
All of the video, because like